Today we'll be discussing about the common misconception that both mass and weight are equal. Weight is a force dependent upon the gravitational acceleration of an object, and that gravitational acceleration of that object is dependent upon the location of the object in the universe, whereas mass is the amount of matter in an object, and it's universal, so it's the same everywhere.
Verify this by
in the universe.
predicting a weight given a gravitational acceleration. With the use of an elevator, we will be simulating this gravitational acceleration.
In order to determine the the simulated gravitational acceleration, we must first determine the elevator's acceleration. So, the elevator first begins accelerating, and then it will reach a point where the velocity is constant, and the acceleration would then be 0 at that time interval. And then before it ends at a stop, it decelerates, and that will give us 3 different accelerations for the whole period of being in
Once
an
we know
elevator.
our elevator's acceleration, then using Newton's second law, we could determine our new theoretical gravitational acceleration.
Which one's the second law? The sum of forces?
Summation of forces equals
Before
ma.
determining our acceleration kinematically, we must first find certain measurable values, which are the height of each floor, the velocity at which the elevator will be at constant acceleration, and the time period at which the elevator starts and ends. One of our values which we will obtain indirectly is distance. The manner in which we will obtain it is by dropping an object like so. And we will record and we will be recording the time at which it takes for that object to hit the ground, and having that, we will use the equation distance equals 1/2 at squared, and finding that value of velocity, distance, we will divide it by 3 since we're on the 3rd floor, and that will give us a rough estimation of the height of distance of each floor. We could find the velocity by simply dividing the distance by simply dividing the distance with the time that it takes for the elevator to travel 1 floor while it's in constant motion.
Another method of determining the elevator's acceleration is to take a video of it as it ascends to the top floor, and then put that video onto a computer to take multiple screenshots of it ascending. Then using that data, we will plot that on a graph of position versus time. Using calculus, we can then determine the acceleration.
Now, after going outside and finding all our tangible values, we can now figure out our acceleration of our elevator. Now, to review, the first thing we need to find is the distance of each floor. Now, the way we're going to do that is we drop a rock and then figure out how long it took for it to travel three stories. After doing that multiple times, we found out that the time it took to travel 3 stories, we had an average time of 1.395 seconds. And with using the simple equation, d equals 1/2 at squared, giving acceleration to be g and t to be 1.395 seconds, gave us a distance of 9.54 meters. Now, since it fell 3 floors, we simply divide by 3, and we found our distance of each floor to be 3.18 meters. So that will give us the distance of each floor. Now, we would find the velocity constant of the elevator. Now, the way an elevator works is it accelerates, reaches a constant velocity, keeps going, slows down to stop. So we need to find the velocity constant at this interval. Now the way we do that is by simply calculating the time it takes the elevator to travel one floor and dividing it and taking the distance divided by that time. That would give us the velocity constant. Now the time it took to travel one floor turned out to give us 1.06. No, it was 3.00 seconds. And given the distance of each floor to be 3.18 meters, by taking the our distance divided by time, that equals velocity. So our velocity is simply 3.12 divided by 3 seconds. So our velocity would be 1.06 meters per second. So now we have the distance of each floor and also the velocity constant reached by the elevator once it reaches constant velocity. So now we'll figure out our acceleration of our elevator using simple kinematics. Now the way we're going to do that is by looking at our elevator again. Now, we traveled 2 floors. Knowing the fact that each floor is a distance known, we know the total distance. So our elevator is going to travel a certain distance. We'll call that D1, where it has an acceleration. Then it'll travel a certain distance, D2, where its acceleration is 0. Now we do know that since we travel 2 floors, D1 plus D2 is equal to total distance, which is equal to 3.18 meters times 2, which gives us 6.36 meters total. All right. So D2 is just simply, well, we'll call the time travels at during this acceleration time accelerated, and we call this time from here to here, we'll call it total time. Time total. So the time it travels at constant velocity would be time total minus TA. So distance traveled in D2 would simply be our velocity constant times time total minus time accelerated. Well, our D1 would be D1 is simply V initial plus V final over 2 times TA. So when we solve this, we'll have D is equal to V initial plus V final over 2 TA plus V constant total time minus time A. Our initial velocity is 0. So this will simply be 6.18 meters is equal to 3.18 meters per second over 2 times TA plus 3.18 meters per second. Our total time we found while we're outside to be 7.32 seconds. And that was done outside, like I said before. So it would be 7.32 seconds minus TA. And solving this will simply give us TA is equal to 2.64 seconds. So that's our time it accelerated. Now, we could simply find D1 to be V final 3.18 meters per second divided by 2 times 2.64 seconds would give us 1.4 meters. Now, using the simple kinematics equation, distance equals 1/2 AT squared. 1.40 meters is equal to 1/2 A. 2.64 seconds squared. So A would be 0.401 meters per second squared. So our acceleration of our elevator is simply 0.4 meters per second squared. Okay. Now that we calculated our acceleration of the elevator to be 0.4 meters per second squared, we will now determine what my apparent weight would be as I accelerate up the elevator. Now, the way we do this by using Newton's second law. Now, given this to be our scale, would have the forces of mg and our normal force. Now, since our summation of the forces is equal to ma, and this thing is accelerating up at 0.4 meters per second, our forces would be our normal force plus mg is equal to ma. So, our normal force minus mg is equal to ma. So therefore, our normal force is equal to ma plus mg. Well, our normal force is our force pushing up, and by Newton's third law, that should equal the force pushing down, which would be the reading on the scale. So our normal force, well, I myself weigh 238 pounds.
All muscle.
Which is equal to 108.2 kilograms. Knowing this, our normal force should be equal to 108.2 kilograms times our acceleration, which is 0.4, and then my mass, 108.2 times g, 9.8. So our normal force would be 1,103.66 newtons. So that should be the reading on the scale. Now, since we don't have a scale that reads newtons, when converted to pounds, this should be 0.66 newtons times 0.225 pounds per newton, should give us 249 pounds. So if we go up to the elevator and I stand on the scale should read 249 pounds. So we will now go and verify if this is true.